All right, so today we're going to be talking about properties of sound. Okay, and so if I said physical science is the greatest, or if I said physical science is the greatest, all right, now you'd be like, whoa, Mr. Grochon, a little intense on that last one. Well, that's exactly what we're going to be talking about today. Well, one of the things we're going to be talking about today, that is intensity, maybe, if it'll move. Here we go. Here we go. So, what exactly is intensity? Intensity, by definition, is it depends upon the amount of energy in a wave. All right, just like if someone's really intense, they have a lot of energy. Okay, intensity deals with energy, and if you remember from a prior video, amplitude. The bigger the amplitude, the more energy there is in the wave. So, more energy in the wave, the more intense it is. So if I take a look at the diagram at the bottom of the screen here, you've got a blue wave and a red wave. Which of these is more intense? If you said the red wave, you'd be right. Why? Because it has a bigger amplitude and therefore it has more energy, which means it's more intense. Now, one of the things we're going to talk about also when we deal with sound is something called loudness. Now, loudness is a perception, all right, of sound intensity, because it's a perception, because what I think is loud, you might not think is loud, or vice versa, right? Because some people have their headphones in and you can hear it from across the room and you're like, dude, turn down. It's way too loud. And like, what are you talking about? I can hardly hear it. That's human perception, right? We measure loudness in something called decibels, okay? That's the measure of intensity of loudness. If you look at the diagram off to the right here, you'll see that as the decibels increase, the loudness increases, and actually it can become painful. So, for example, like an alarm clock, around 80 decibels, right? Lawnmower, around 90 decibels. So why do we care about how loud something is, right? Other than it being annoying? Well, if things get too loud, what can happen is actually you can damage your hearing. So let's take a look at hearing loss. How does hearing loss take place? Well, if you remember back in the video talking about the parts of the ear, you've got your outer ear, which is the cartilage that kind of funnels the sound to your eardrum. You got the middle ear, which is made up of your three tiny bones, right? That kind of convert the sound wave into mechanical motion. And then you have your inner ear, made up of the cochlea. And we said that was fluid filled. Well, in this cochlea, which is fluid filled, you have got these little tiny hairs. So you can see here's a microscopic diagram of what they kind of look like. Now those little ears kind of sit there and they'll bound wave back and forth as the energy from the sound that you're hearing passes into that. And so the stronger the energy of the wave, the more they're gonna bounce back and forth. Well, if just like a tree that's blowing in the wind, if you've got too much energy and it bounces, it bends too much, it'll break. Well, same thing can happen with these hairs. When those hairs break, that's when we start losing our hearing. Now, hearing loss can happen naturally as you get older. Okay, the hairs just like anything else. As you get older, trust me, you get older, you get stiffer, and the hairs get stiffer, and they'll start breaking off. And as they break off, and they become shorter and shorter and shorter, you start hearing less and less of the frequencies out there. Another way of hurting your ears is by, like I said, having too much energy. 120 decibels can cause hearing loss around there. Or if you have decibels at a lower range, say like 80, 90 decibels, but for a long period of time, that also can damage your hearing. So people that have their earbuds in all the time, but have it up pretty high, but not like at 120, but say like 100, but they have it in for like 10 hours a day. Over time, that's going to cause hearing loss. Not necessarily right away. You're not going to wake up one day and say you can't hear anything. It's going to happen gradually over time. So here's a picture or a diagram of that right here. So at 85 hours of continuous listening, you can have about 8 hours. Now, as you can see up here, 97 decibels, you can have about 30 minutes. Well, let's take a look over here. Here are some decibels of like a motorcycle, right? At 100 decibels, technically after 15 minutes, you should be having some way of kind of dampening that that sound either through, earmuffs or something. Otherwise, you have run the risk of losing your hearing. Now, pitch. What is pitch? Pitch is the highness and lowness of sound. Now, pitch is dependent upon the frequency. As frequency increases, all right, so the wavelengths are shorter, the higher the pitch is going to be. So, the Doppler effect. The Doppler effect is a change in the wave frequency due to the wave source moving relative to an observer, or an observer moving relative to the wave source. Okay, so we've heard a fire truck before going woo 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 woo. All right, or as it doesn't sound like that the whole time, right? It normally doesn't sound like that, but when it's moving, it does. Well, why is that? Well, that's because, like I said, of the Doppler effect. So what happens is that the woo of the vehicle is constant. But the vehicle is moving, and if you're standing still, what will happen is, if we take a look at the picture here down here, the waves get closer together, which means it has a higher frequency. The higher frequency of a wave means it has a higher pitch. So it goes like woo, right? And then afterwards, because it's moving at a consistent rate, but the vehicle's moving away. Now, all of a sudden, behind the vehicle, those sound waves are farther apart, which means it has a lower frequency, so it's going to be like a woo, right? And so, as the vehicle is coming towards you, it's going woo, 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 and then when it goes by you, it goes woo, 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 woo. Or a lot of times in like racing, what does race car sound like? Right? So you have a high, and then as it passes you, it gets low. Right? So that's the Doppler effect. All right, so those are the properties of sound that we're going to be talking about today. If you'd like to get more information about this, there are links within the slideshow. Either click on the link in the description, and that'll take you to that, and you can then get more information if you would like.